It comes from a quiet backyard on the edge of town. On the morning of December the 29th at exactly 12:47 a.m, Ray Calderon took a photo that would stop the scientific community in its tracks. He wasn't working for NASA. He didn't have access to the James Webb or the Hubble. His lab was a wooden shed tucked between a line of sycamores. His equipment? A modest Dwarf 3 telescope cooled only by the crisp December air and a cup of black coffee resting beside it. And yet what he captured would echo louder than any press release. Ray had been tracking 3i Atlas for over a week. Like many in the amateur astrophotography community, he had a personal fascination with interstellar visitors, especially this one. Atlas was already surrounded by strange reports. Its behaviour didn't match what a comet should do. Some images showed faint structure. Others hinted at odd brightness shifts, but no one had seen it clearly. Not yet. So Ray tried something different. He waited for the moon to set. Then he stacked longer exposures. He used narrowband filters to block out ambient light, and when the image finally rendered on his laptop screen, he stopped breathing. This wasn't a comet, not the kind we were taught to recognize. Not a blurry ball of dust streaking away from the sun, not a hazy object shedding itself in all directions. No, what Ray saw had definition, shape, boundaries. The nucleus was bright, too bright. And surrounding it was a smooth, soft glow of blue that wrapped around the object like a halo. But it wasn't diffusing. It wasn't spreading. It was holding, contained. In that moment, Ray didn't think about history. He didn't think about headlines. He thought about whether his gear had glitched, whether he'd overexposed or misaligned the stack. He reran the images twice, then he ran them again with different filters. Every time, the same thing emerged: structure. He posted the image online. He added no claims, no caption screaming, "Alien!" or "Proof!" Just the data. A raw composite. And then, within 14 minutes, the internet responded. Astrophotographers across multiple continents began downloading, dissecting, and comparing. And the response was immediate. Not denial, not skepticism, but replication. Others had captured something similar. Some hadn't processed it. Some had dismissed it as sensor error. But now, with Ray's frame as reference, they looked again and saw it. Within 3 hours, Ray's image was in the inbox of a heliophysics analyst at the European Space Agency. By sunrise, it had been posted in private Slack groups run by planetary science researchers. By midday, it had circled back to NASA's Planetary Defense Coordination Office. But none of that changed what had happened. A man, a telescope, and one clear winter night had exposed something buried in the noise. Not just a comet, but a contradiction. Because comets are supposed to blur, to fragment, to fade under pressure. This object didn't. It sharpened. It brightened. It clarified. And Ray Calderon, astrophotographer, amateur scientist, was the first to catch it in motion. Not because he had better hardware, but because he was looking, carefully. And now, because of that one frame, the official narrative was beginning to unravel. Because sometimes the truth isn't waiting in an observatory, it's waiting in a backyard. In astronomy, pattern is everything. We catalogue the sky by repetition, how objects behave, how light shifts, how movement translates into equations. For comets, the pattern is well worn. Approach the sun, heat builds, ice sublimates, gas escapes, dust follows, the coma expands, a tail forms, the object glows, not because it wants to, but because thermodynamics makes it do so. The beauty of comets is in their chaos. But Ray's image didn't show chaos. It showed control. It didn't belong to the standard playbook. What Ray captured with a consumer telescope in a quiet, residential backyard wasn't just anomalous. It was impossible under known comet models. Because while the image showed brightness, it lacked blur. While it showed glow, it lacked diffusion. And where there should have been messy, asymmetric outgassing, there was geometry. Edges were defined. The glow was even. The shape was coherent. To the naked eye, it resembled something engineered, not something ejected from the icy graveyards of space. And yet, there it was, hanging in the void, captured in a still frame. The forums erupted. Experts weighed in. Could it be over-processed? Was it just a contrast-enhanced illusion? Was stacking software smoothing out the coma and creating artificial structure? That was the prevailing theory, until the second image surfaced. Captured hours later by an amateur in Madrid, it showed the same configuration. Blue edging, compact form, no streaking, no bloom, just a bright central object, tightly wrapped by a shell of light. Then came the third image, this time from a telescope array in Brazil. Then another. And by dawn, Ray's discovery had been confirmed by half a dozen observers, all using different equipment across multiple continents. The arguments shifted from artifact to interpretation. People weren't denying what they saw anymore. They were trying to explain it away. Some said the structure might be due to lens flare. Others floated exotic particle scattering. But none of those models accounted for one thing: consistency. Each image came from a different angle, different weather, different optics. But the object remained the same, sharp, structured. And then someone made a side-by-side comparison. Ray's photo versus Hubble's. The difference was jarring. Hubble's image, taken just a week prior, showed a faint bloated blur, typical comet profile. But Ray's image had edges, lines, direction. The community couldn't ignore it anymore, and so the question became louder, clearer, more urgent. Why do official observatories show haze while amateurs now see hardware? Theories ranged from benign to unsettling. Maybe the pro images were filtered differently. Maybe they used processing software to intentionally reduce oversharpening. Maybe, and this was whispered quietly, they were masking something, not for deception, but for stability. Because if Ray's image was true, if that shape was real, then everything about 3i Atlas would need to be rewritten. It would mean this object wasn't just behaving oddly. It wasn't a comet playing rough. It was something else entirely. And Ray, unintentionally, had just taken the photograph that cracked the narrative wide open. For decades, space belonged to institutions, to the domes atop Mauna Kea, to the time slots booked years in advance on the Hubble, to the polished press releases from NASA and ESA, written in careful, vetted language. The public was allowed to see, but only what they were shown. The narrative flowed from the top. But on December 29th, that hierarchy cracked, and it cracked in the form of a photograph taken by a man named Ray, from a backyard. Ray's telescope, the Dwarf 3, was not a marvel of engineering. It was accessible, portable, a tool built not for discovery but for passion. And yet somehow it captured what multi-billion-dollar observatories had not, or more precisely, what they had not shown. This wasn't just a story about one image. It was a story about access, about who gets to see what and when. Because for weeks leading up to Ray's discovery, official space agencies had been observing 3i Atlas. They had eyes on it from every angle. Hubble in low Earth orbit, JWST in deep space, SOHO near the Sun, and ground-based arrays scanning in infrared, radio, and ultraviolet. But their images all showed the same thing: a soft sphere, a dusty coma, a nondescript visitor that looked like 1,000 other icy bodies. Nothing structured, nothing strange. And then Ray, with his small backyard setup, captured something so sharp, so defined, that the image alone forced the narrative into question. How? How could a consumer telescope outperform the Hubble? At first, the answer seemed obvious. It didn't. Hubble's instruments are more sensitive. Its optics are leagues ahead. But that wasn't the real issue. The real issue was what gets published and what gets processed out. Because professional observatories aren't taking snapshots. They're collecting vast arrays of raw data, much of it inaccessible to the public in its unprocessed form. What we see, what we're allowed to interpret, often comes after layers of filtering, cleaning, calibration, and assumption. Ray's photo had no such layers. It was raw, imperfect, but honest. And in that honesty, it revealed something staggering. As other amateurs across the globe confirmed the structure, scientists began whispering another possibility. Maybe the pro observatories saw it too. Maybe it's there in the raw frames. Maybe it was simply smoothed out, removed, deemed artificial light, or instrument error. Not out of conspiracy, but out of protocol. Because when your models say comets are chaotic, you design your processing pipeline to ignore symmetry. You treat edges as noise, structure as flaw, geometry as error. Ray's photo didn't follow protocol. It followed photons, and that may have made all the difference. What happened next wasn't revolution. It was something quieter, but more powerful. Researchers began reaching out, not officially, not through press releases, but in private channels, quiet emails, discreet messages asking for image files, timestamps, telescope specs. Because even inside the walls of institutional science, something had shifted. The boundary between amateur and professional had thinned. For the first time in years, backyard astronomers weren't just enthusiasts. They were early eyes, the ones finding what billion-dollar instruments filtered out. Ray's discovery didn't prove deception. It proved dependence. That science had grown so confident in its models, it stopped looking for outliers. And so, when a single man with a single image changed the tone of the conversation, the space agencies had a choice: ignore it, or begin again. To their credit, many chose the latter, because science doesn't belong to titles, it belongs to truth. And sometimes truth shows up not in a lab, but under a dark sky, beside a wooden shed, with a telescope barely bigger than a backpack. And that's what happened on December 29th. A photograph broke the pattern, and reminded everyone, discovery has no rank. At first glance, light seems simple. It bounces, it reflects, it scatters. In astronomy, we use light to measure everything: distance, velocity, composition, and heat. When sunlight hits a comet, it reflects off the dust. The brightness we see is just borrowed energy. There's no internal light, just mirrored radiation. But the glow around 3I Atlas, captured in Ray's photo, didn't behave like a reflection. It looked active, alive, and that changed everything. Because in Ray's image, and in those that followed, the glow wasn't diffuse, it was contained. It wasn't fading into the surrounding vacuum like a coma should. Instead, it followed the object's curvature. It hugged the shape with eerie precision, almost like an envelope, a shell, a field. That's not how comets glow, not even close. Scientists noticed something else. The light wasn't falling off naturally with distance. There was no smooth brightness gradient like you'd expect from reflected sunlight scattering across dust. Instead, it dropped suddenly, like it was being confined, cut off, shaped. And that sharp cut-off meant one thing. This wasn't passive reflection. It was emission. Meaning, the light was being generated, not bounced. The implications of that are enormous. For a natural body like a comet, there are only a few reasons light might be emitted. Chemical reactions, ionization, electric discharge, but those processes are chaotic, messy. They scatter in all directions. What Ray captured, what others confirmed, was the opposite: symmetrical, stable, almost efficient. Astrophysicists began reviewing past comet data, searching for precedents, but none of the known interstellar or long-period comets had ever shown this kind of controlled emission. Even 2I Borisov, the second interstellar object, glowed with traditional cometary scatter. So where was this glow coming from? A few possibilities emerged. The first was ionized gas. Maybe the blue hue was from CO+ ions fluorescing under solar radiation. That would explain the colour, but not the shape, not the containment. The second possibility, magnetic interaction. Maybe 3I Atlas had an induced magnetosphere, a bubble formed as solar wind wrapped around a conductive object. It would explain the curved sheath of light. But again, for a natural body to generate that kind of magnetic envelope, it would need specific surface conductivity and internal structure we've never seen. The final possibility, artificial containment. Not a magnetic bubble, but an electromagnetic one. A glow caused by energy being directed, shaped, managed. At that point, the conversation crossed an invisible line, from natural physics to theoretical systems. Because if this object is emitting light in controlled arcs, it suggests systems. If the glow is concentrated only around the fuselage, not the tail, it suggests purpose. And if it's consistent over time, as Ray's sequence of images indicated, then we're not looking at a random event. We're looking at a behavior, a signature, or maybe a technology. No one in the mainstream dared say that out loud, but in the forums, in the Slack threads, in the late-night calls between citizen scientists and physicists, the question was growing. What glows like a field What emits light like it's regulated? And most of all, what kind of object enters our solar system and starts turning sunlight into something else? Whatever it is, it's still glowing. And now it's not just amateurs who are watching. By the time Ray Calderon hit upload, he was still doubting what he had seen. Even as the image loaded to his forum thread, he expected to be corrected. For someone to comment with an easy explanation, a lens error, a bad stack, a software glitch. That's how it usually went. The world of amateur astrophotography is built on refinement, not revelation. But this time, there was no dismissal. There was only replication. Less than an hour after Ray's post went live, another observer chimed in, this one from Madrid, Spain. His name was Esteban. Different hemisphere, different time zone, different telescope, and yet his image looked almost identical. Same glowing core, same bluish wrapping, same eerie clarity. At first, Esteban thought he had made a processing mistake. But when he saw Ray's upload, he knew he hadn't. They matched, line for line, shape for shape. Then came another post, from Western Australia, then a third, from Ontario. Within 3 hours, observers from 5 different countries had submitted aligned frames, all showing the same thing. 3i Atlas was not a messy ball of ice and dust. It was defined, stable, almost engineered. Each image was taken using different optics, different brands, different exposure times. Some were filtered, some weren't, but the structure was consistent. The confirmation was undeniable. What Ray had seen wasn't a fluke, it wasn't a glitch, it was real. And with each new image came an echo of the same conclusion. The shape was not random. The glow wasn't scattering. The object had clear, repeating features that held their form across miles, minutes, and machines. Astrophotography forums, once slow and patient, lit up like a circuit board. Image comparisons, contrast overlays, rotational simulations. People weren't just talking, they were analysing. The conclusion was emerging. This was not the behaviour of dust. Comets don't hold form like this, especially not after perihelion, especially not after solar exposure. If these observations had come from a single telescope, they would have been dismissed. But they didn't. They came from a mosaic of watchers, spread across the Earth, working independently. And that's what changed the conversation. No longer could the official line hold that 3i Atlas was just another frozen wanderer from deep space, reacting predictably to sunlight. Because now, the public had proof that something about this object wasn't reacting. It was holding. It was organised. It was being seen. And the most extraordinary part, none of the amateur observers knew each other. They didn't coordinate. They didn't plan. They weren't trying to make headlines. They were just looking. And what they saw matched. For the scientific community, this moment marked a shift, a tipping point. Not because it revealed a secret, but because it revealed agreement. This wasn't a one-off. It was a phenomenon, and it had just gone global. To understand why Ray's photo, and the confirmations that followed, are so significant, you have to understand what a comet is supposed to look like. At their core, comets are wanderers, leftovers, primordial rubble from the edges of solar systems. They're made of frozen water, carbon dioxide, carbon monoxide. Ice is locked together with dust and rock. Often described as dirty snowballs, they orbit in long eccentric paths, mostly quiet until they approach a star. When a comet gets close enough to the sun, everything changes. The heat kicks in. Solar radiation causes the ice to sublimate, turning directly from solid to gas. That gas escapes from the comet's surface, carrying dust with it. Together they form the coma, a cloud of gas and dust that surrounds the nucleus. From there, the solar wind takes over, pushing the material into a long tail that always points away from the sun. The process is beautiful, but it's also chaotic. Comets don't glow evenly. Their brightness fluctuates. Their tails wobble. The coma expands and contracts. Jets of material erupt from random patches, depending on the rotation of the body and the uneven heating of the surface. In most telescopic images, comets appear fuzzy, soft, slightly asymmetric, like a cloud lit from within. What they never look like is structured. But Ray's image wasn't fuzzy, it was sharp. It wasn't asymmetric, it was balanced. It didn't look like a cloud, it looked like an object. This is where the contradiction begins, because if 3i Atlas were following the known laws of cometary behavior, it should be unstable right now. It passed close to the Sun, it experienced solar heating, it should be shedding mass, venting unpredictably, disintegrating. Instead, it's glowing evenly, it's holding symmetry, and its jets, rather than appearing randomly, seem aligned, fixed. The brightness isn't fading, it's stable. That's not a comet's profile, that's an engineered profile. But here's the problem. The data does show signs of sublimation. Radio observatories have detected hydroxyl signatures, fragments from water molecules breaking apart under UV light. That's normal comet activity. It confirms there's ice on board, but if ice is present and sublimation is happening, why isn't it creating the expected cloud? Why isn't the coma expanding? Why aren't we seeing the diffuse mess that usually defines a post-perihelion object? There's a gap between cause and effect. The data says, comet. The image says not even close. One possibility is that 3i Atlas is built differently, that its surface is unusually cohesive, able to vent gas in straight, consistent jets without tearing apart. Another possibility is that the jets themselves aren't caused by natural heating, but by internal systems. Systems that regulate venting, systems that control orientation, systems we don't associate with nature. Either way, what we're seeing now doesn't match the expected behavior of any known comet. And that's the real issue. Because science doesn't just rely on data, it relies on models, and those models are breaking, which means either this object is a new kind of natural, or it's something else entirely. Something that's still holding form long after it should have fallen apart. And the longer it holds, the more questions we're forced to ask.